In this section 9.3, we're going to talk about all the different matrix operations and applications of that, basically solving matrix equations using operations. Okay. Now those operations involved addition of matrices, subtraction of matrices, multiplying a matrix times a scalar. When I say a scalar, it means multiplying it times a number, and multiplication of two matrices. Now we're going to start with some notations that you need to know about matrices. Very important information. Now the first thing is, of course, a definition of a matrix. An array of numbers arranged in rows and columns and placed in brackets is called a matrix, as we discussed back in section 9.1. We can represent a matrix in two different ways. Number one, this is the main way that we represent it as. A matrix can be represented by using a capital letter, such as matrix A, matrix B, matrix C, and so on. It can also be represented with a lowercase letter enclosed by brackets, followed by two little digits. Okay, those two little digits that you have right next on sub-indexes that you have right next to that matrix A are basically the number, identify the number of rows and the number of columns of that specific matrix. So it is more general. Okay. Now, if I want to refer to a general element in the matrix, meaning a general element means one of the numbers or one of the values in the matrix, I can represent it with this notation, with that same notation that we have enclosed by the brackets, Aij. What does it mean by that? It is an element from matrix A located in the ith row and jth column. So it's basically identifying any specific element in a given matrix. In the second row, third column, the element located in the fourth row, second column, and so on and so on. So we're going to start with this problem. First of all, we're going to give the order of this matrix, and then we're going to, I forgot to give the definition of order before we go to this, so we're going to go back to the problem. So this is my second concept that you need to know. A matrix of order n by n. When I say order, the word order means that the dimensions of the matrix. Dimensions. When I say dimensions, means the size of the matrix. And the size can be represented in terms of rows and columns. It is always the row first and then the column. So when I tell you the matrix has order n by n, that means that it has m rows and n columns. So the first one is the rows, the second one is the columns. And one little fact here, if the number of rows and the number of columns are the same, then that means that the matrix is a square matrix. Let's go ahead and do this problem now. Question A. We want to give the order of the matrix on the right. So if we look right here, how many rows does this matrix have? It is 3 rows. And if we look right here, how many columns does this matrix have? It has 4 columns. So that means the order is going to be a 3 by 4. Remember that the row is always first and then the column. Next, letter B. We are going to identify two elements. You see that they want you to identify A3, 2. What does it mean by that? It means that you want to find the element located in row 3. This is my row 3 right here, but column number 2. This is my column 2. So which one is the only element that is in row 3, but at the same time column number 2? That is the number 1/6. Now let's find the other one, A3. What does it mean by that? We want to identify the element that is situated or located in the second row. That's what the 2 first mean. But at the same time, in the third column. The third column is this one right here. So which is the element situated in row 2, column 3? -6. Okay. And those are the general notations of matrices that you need to learn first for this section 9.3. Now, we're going to talk about equality of matrices. Two matrices are equal if and only if they have, number one, they have the same order, but also the corresponding elements from one matrix to the other matrix are equal, meaning that the element in the first row, first column must be equal to the element in the first row, first column of the other matrix. The element in the second row, first column must be the same as the element in the second row, first column of the other matrix, and so forth. So that's what needs to be true in order for two matrices to be equal to each other. They must have the same order, and the corresponding elements must be equal. Let's go ahead and work on this problem. Find the values of the variables so that the following matrices are equal. That's what we want to find out. Find the values of the variables so that the following matrices are equal. So, what must x needs to be so that it is equal to this number on the right side? It is a very simple thing. X must be equal to 7 so that it is equal to the other side. Right? So that is my first value. X is equal to 7. Now, we know that this for y must equal to 4. But if for y must be equal to 4, then that means that y must be equal to 1. Because if I divide both sides by 4, I'm going to get y equals to 1. And last but not least, the z must be equal to the 20. So z must be equal to the 20. And those are the three values of x, y, and z for which these two matrices will be equal to each other. Now these two are already equal. 2 equals 2. Now, let's discuss about the operations of matrices. This is what the main topic for this section is going to be. Now we have matrix addition and matrix subtraction to begin with. Now, we're going to talk about corresponding elements again. For matrix addition or matrix subtraction, first of all, one little thing is that both matrices must have the same number of rows and the same number of columns in order for the two matrices to be able to add or subtract to each other. That is one thing that we need to keep in mind. Now, how does addition and subtraction works? We just add or subtract the elements in the corresponding positions. For subtraction, same thing. Subtract the elements in the corresponding positions. So, for example, the element in the first row, first column, if I add it to another matrix, I need to add it to the element in the first row, first column. That's what you see right here. The element in the first row, second column needs to be added to the element in the first row, second column. The element in the second row, first column needs to be added to the element in the second row, first column. And the element in the second row, second column needs to be added to the element in the second row, second column, and so forth. So we need to add or subtract corresponding elements of the two matrices when we're adding or subtracting. Either one is the same idea. Now, we're going to discuss about the definition of scalar multiplication. Now, what does it mean by scalar multiplication? I mentioned it to you. It means multiplying a matrix by a number. So if I give you any given matrix A, and I say C times A, where C is a number, all you gotta do is multiply each element in matrix A by that real number C. That's what that C times A means. Multiply each element in that given matrix A by that given number C. Next, Let's go ahead and answer this question about these four questions here. Find the following matrices where A equals 9596 and B equals 6973. First operation that we want to do, it says find A plus B. That's the first thing we're going to find here, A plus B. Meaning we're going to add matrix A, which is 9596, plus matrix B, which is 6, 9, 7, and 3. We're just going to add them with each other. And according to the definition, remember that we must add the corresponding elements. So the first row, first column, first row, first column. Then we're going to add the number in the first row, second column with the number in the first row, second column. Then we're going to add the number in the second row, first column with the number in the second row, first column. And finally, the number in the second row, second column, we add it to the number in the second row, second column. So in this case, it's going to be 9 plus 6 for the first element, which is going to be a 15. Then 5 plus 9 for the second element, which is a 14. Then 9 plus 7 for the third element, which is a 16. And 6 plus 3 for the last element, which is going to be a 9. And that is my answer for my matrix A plus B. Now, for A minus B, we're going to do the exact same thing, because remember, for matrix addition or matrix subtraction, we're going to do the exact same thing. We're going to add and subtract the elements in the corresponding positions. That's how we do it. So for this subtraction right here, we're going to do the exact same thing that we did for the addition. The element in the first row, first column is going to be subtracted to the element in the first row, first column. So we got 9 minus 6, which is a 3. The element in the first row, second column is going to be subtracted to the element in the first row, second column. So it will be 5 minus 9, which is negative 4. The element in the second row, first column, it's going to be subtracted to the element in the second row, first column. So it will be 9 minus 7, which is going to be a positive 2. And the element in the second row, second column is going to be subtracted to the element in the second row, second column. So it's 6 minus 3, which is positive 3. And this is the solution to my matrix A minus B. Now, this one says negative 4A. What does that mean by negative 4A? It means simply that we are going to multiply everything in this matrix A by that negative 4. So once again, everything in this matrix A is going to be multiplied by that negative 4. And if we do that, negative 9 times negative 4 is negative 36. 5 times negative 4 is negative 20. 9 times negative 4 is negative 36. And 6 times negative 4 is negative 24. And this is the solution for my matrix negative 4A. Last operation, 3A plus 2B. What does that 3A plus 2B means? Let's talk about that. First of all, it tells me that first I need to multiply everything in matrix A right here. I need to multiply it by 3. That's what the 3A, first of all, stands for right here. Multiply everything in matrix A by a 3. Then you are going to multiply everything in matrix B by a 2. So that's what the 2b means. Multiply everything in matrix B by a 2. And last, we are going to add those two matrices. Okay? So then we're going to get, for 3a, we're going to get 27 plus 15 plus 27 and 18. And we're going to add them to the values of matrix 2b. Matrix 2b is going to be a 12, an 18, a 14, and a 6. Now remember that addition and subtraction is just component wise. What does it mean by component wise again? That the number in the first row, first column is going to be added to the number in the first row, first column. So which is 27 plus 12, it's a 39. The element in the first row, second column, is going to be added to the element in the first row, second column, which is going to be 15 plus 18. That's going to be a 33. The element in the second row, first column, is going to be added to the element in the second row, first column, so which is 27 plus 14, that's a 41. And last but not least, the element in the second row, second column, it's going to be added to the element in the second row, second column, so that's 18 plus 6, that's a 24. And this is going to be the resulting matrix 3a plus 2b. Next idea. Now we're going to use this in solving matrix equations. So before we go into the last operation, which is multiplication of matrices, I'm going to skip this for a minute. We're going to solve a matrix equation. Let's solve this problem right here. Okay, this basically we're going to use all the concepts that we just learned from scalar multiplication and from matrix addition and matrix subtraction. It tells me, let A be equals to negative 6, 4, 9, negative 6, negative 7, negative 7. And let B be equals to 1, 6, negative 3, 7, 9, negative 3. Question is, we want to solve the matrix equation 3x, negative 3x plus 5a equals b. Meaning that we want to find a matrix x so that when I multiply that matrix times negative 3 and I add it to 5 times the matrix A, it's going to be equal to my matrix B. So the question is, find that matrix X that satisfies this equation. So we're going to treat it as a regular equation, meaning that the first thing I want to do here is I want to solve this equation for X to see what X is to see what type of operations or what kind of operations is X going to consist of. So first, if I want to solve this equation for X, in other words, or leave the X by itself, I need to first move the 5a as a minus 5a over to the other side. So that gives me negative 3x equals negative 5a plus b. Then, to get rid of that negative 3, we can either multiply by negative 1/3 or divide by negative 3. Because if I say multiply by negative 1/3 means divide by negative 3. Right? So you can say it like this. Negative 5a plus b divided by negative 3. Or you can also say it like this. Negative 1/3 multiplies times negative 5a plus b. So that's the same thing either way. So what does this tell me? That in order for me to find that matrix X, I need to multiply matrix A by negative 5, then I need to add it to matrix B, and then I either divide all the values by negative 3 or multiply all the values by the scalar negative 1/3. Okay? So that's what we're going to do to find the matrix X. So I'm going to set everything up right here on the side. So it would be x equals to negative 5a. So that's the first thing we are going to do. Multiply everything in a, which is negative 6, 4, 9, negative 6, negative 7, and negative 7 is going to be multiplied by negative 5. That's the first thing we see here. Then what we're going to do next, we're going to add it to matrix B. So we're going to add this to matrix B, which is 1, 6, negative 3, 7, 9, and negative 3. And last, we are going to either multiply all the values by negative 1/3, or you can say divide all the values by negative 3. Okay. So let's follow with the rest of the operation. So first of all, I'm going to multiply all those values by negative 3 right here. So if I multiply them by negative 5, it's going to be a 30 right here. It's going to be a negative 20. Then it's going to be a negative 45. Then it's going to be a 30. Then it's going to be a 35. And then it's going to be a 35. Then we need to add them to B, which is 1, 6, negative 3, 7, 9, and negative 3. And then we're going to divide all the values by negative 3, or multiply all the values by negative 1/3, which is, like we explained, it is the exact same thing. So remember that when we add them, we need to add them component-wise, meaning that the element in the first row, first column is going to be added to the element in the first row, first column. So that is going to give us a 30 plus 1, which is going to be a 31 right here. Next, the element in the first row, second column, it needs to be added to the element in the first row, second column, which is negative 20 plus 6. It's going to be a negative 14. Now, the element in the second row, first column, needs to be added to the element in the second row, first column, which is negative 45 plus negative 3, that's negative 48. And the element in the second row, second column, needs to be added to the element in the second row, second column, which is 30 plus 7, that's a 37. Next, the element in the third row, first column, to the element in the third row, first column, we're going to add them, and that is going to be 35 plus 9, which is a 44. And last but not least is that the element in the third row, second column, needs to be added to the element in the third row, second column, so that would be a 35 plus negative 3, which is a 32. So we did multiply A by negative 5, then we added to matrix B, but now we're missing one more thing. We're going to divide or multiply, divide all the values by negative 3, or multiply each value by negative 1/3, which is the exact same thing. And that will complete what we are looking for. So, 31 divided by negative 3 is negative 31/3. Negative 14 divided by negative 3 becomes a positive 14/3. Negative 48 divided by negative 3 is positive 16. 37 divided by negative 3 is negative 37/3. 44 divided by negative 3 is negative 44/3. And 32 divided by negative 3 is negative 32/3. And this is my matrix X. So my matrix X is equal to this matrix. So if I multiply this matrix, if we go to the original equation, let me explain to you what this means. if this matrix is multiplied by -3 according to the original equation, -3x, multiply that matrix by -3, and then we add it to 5 times the matrix A, which is this matrix that we got here, it's going to equal to that matrix B right here on the right side. Alright, so that's how we solve a matrix equation. We mainly use the operations learned in addition of matrices, subtraction of matrices, or multiplying a matrix times a scalar. Okay. Now, the last operation that we're going to learn is matrix multiplication. This is what you need to know now to finish this up. The product of an m by n matrix A and an n by p matrix B is an n by p matrix AB, whose elements are found as follows. Now, first of all, let's look at this. In order for two matrices to be able to multiply, this is what you have to keep in mind. The number of columns of the first matrix, which is the n that you see right here, that's the number of columns, must be the same as the number of rows of the second matrix. And that's what it tells you right here on the bottom. For the product of two matrices to be defined, the number of columns of the first matrix must equal the number of rows of the second matrix. And your resulting matrix for that product or multiplication is going to be the number of rows of the first matrix, that's what you see here, by the number of columns of the second matrix. That's how many rows and how many columns the new matrix AB, whenever you multiply them, that's what the new dimensions of that new matrix is going to be. Now, how do we multiply the values? It tells you the elements in the ith row and jth column of AB is found by multiplying each element in the ith row of A by the corresponding element in the jth column of B. So let me give you an example. If I want to find an element that is located in the, like on my new matrix, I want to find an element from, let's say, the first row, first column, what I need to do is multiply the first row of the first matrix times the first row of the second matrix. Now, let's say if I want to find the value of an element that is located in the third row, second column, then I need to multiply the third row of my first matrix times the second column of my second matrix. And you're going to do that until all the elements are filled in on that new matrix that you created. So, let's go ahead and take a look to two examples of multiplication. Okay, so we're going to start with this. Find, if possible, A times B and B times A. Or let's do this one. This one's best. Find, if possible, A times B and B times A. So let's start with A times B. Now if you look at A, right here, A is -4, 4, 3, 3, 3, 1. What can we say about the dimensions of A? This one is a 3 rows by 2 columns. Now multiply times B, which is 1, 2, 5, and then we have a 4, 2, and -2. -2. Okay? So what can we say about B? That B has 2 rows by 3 columns. So in order for two matrices to be multiplied, so for the multiplication to be possible, we need to check that the number of columns of the first matrix is equal to the number of rows of the second matrix. In other words, the two numbers in the middle of the dimensions must be equal. And my final matrix is going to be the first dimension by the last dimension, which is going to be a 3 by 3 matrix. So when I multiply these two matrices in that manner, AB, this is going to result into a 3 by 3. And I'm just going to put that what it means here. It means that my new matrix is going to contain 3 rows and 3 columns. So this is basically how it's going to look like. 3 rows, but also there's going to be 3 columns right here. That's what we're going to have. Now, this is what it was telling you on the definition of how you multiply them. So that's what I want to show you next. So I'm going to put my answer on the right side right here. Okay. Now, that's what I was telling you. Now, this number on the first little box, on the first line, it is located in the first row and first column, right? So what I need to do to find the answer to this number is that I need to multiply the first row of the first matrix, which is the -4 and the 4, times the first column of the second matrix, which is the 1 and the 4. And you multiply them in the order in which they appear. The first by the first, and the second by the second. Okay? So in other words, -4 multiplied times the 1, and the 4 multiplied times the 4. And whatever you get for these two, you're going to add these answers. So this is going to give me a -4 plus, and this is going to be a 16, and that's going to give me a 12. So the first value is going to be 12. Now, what about this one on the right? What can we say about that? It is located in the first row still, right? But on the second column. So what I need to do to find that value is multiply the first row again, right here, but now times the second column, which is this one. And you multiply them in the same order. The first times the first value, the second times the second, and then you add the results again. The -4 times 2 plus, and then the 4 times the 2. So this is going to give us a -8 plus, and that's going to be a +8, which is going to give me a 0. Now, what can we say about this element on the bottom? That one is on the right side. That one is located in the first row, third column, right? First row, third column. So that means that we need to multiply the first row, which is this row again, but now times the third column, which is that column on the right side. So you multiply the first times the first, and the second times the second, and then you add them. So that's -4 times 5 plus 4 times -2, and then I'm going to add the results. -4 times 5 is -20, plus 4 times -2 is -8. So -20 plus -8 is -28, and that would be this value on the right. Next, how do we find this number at the bottom? That one is located in the second row, but in the first column. So what I need to do to find that answer is multiply the second row of the first matrix right here times the first column of the second matrix. Second row of the first matrix times the first row of the second matrix. So we're going to multiply the first times the first, the second times the second, which is going to be the 3 times the 1 plus the 3 times the 4. So it's going to give me a 3 and a 12. When I add them, that's going to be a 15. Next, this one in the middle, it is located in the second row, but the second column. So what I need to do is I need to multiply again the second row, which is this row again, but now times the second column, which is the middle column. Okay, and then you multiply the first times the first, which is 3 times 2, and the second times the second, which is 3 times 2. And then we add them. 3 times 2 plus 3 times 2, that's a 6 plus 6, which is going to give us a 12. Now, the rest of them I'm going to do it with a pen, so I don't have to write more. Or let me see if I can change at least one of the colors here. Let me change it to this. Okay. Now, what can you say about this number on the right side? It is located in the second row, but the third column. So how do I find it? By multiplying the second row again, which is this one, but now times the third column right here, which is this one. You multiply the first one times the first one, which is the 3 times the 5, and the 3 times the -2, and then we add the results. 3 times the 5 plus, and then the 3 times the -2, so it's going to give us a 15 plus -6, which is going to be a 9. Now we're going to find the last three values. Now this one is located in the third row, first column. So what you need to do to find that answer is this. You need to multiply the third row of the first matrix times the first column of the second matrix. So it would be the 3 times the 1 plus the 1 times the 4. That gives me a 3 plus 4, which is going to be a 7. So that value is going to give us a 7. Now, how do we find this one? This one is located in the third row, second column. So what I need to do is multiply the third row, which is this one again, but now times the second column, which is this middle column. So you multiply them in the order in which they appear, which is the 3 times the 2 and the 1 times the 2, and then we add them. So it's going to be a 6 plus 2, which is going to be an 8 for this value. Last but not least, this one is located in the third row and third column. So I need to multiply the third row, which is this row again, but now times the third column, which is this column right here. So it would be the 3 times the 5 plus the 1 times the negative 2. So that's a 15 plus negative 2, which is going to be a 13. And this is my matrix A times B. So a lot of people might think that because AB is equal to this, if I do BA, shouldn't it be the same? Matrices doesn't work just like the regular number system. Okay? Multiplication is not commutative in matrices, meaning that A times B is not the same as B times A. So now we're going to find BA. That's the next operation we are going to do. That's what we're going to find, B times A. And you will see that they're not the same at all. So now we're going to multiply B, which is 1, 2, 5, 4, 2, negative 2. We're going to multiply times my matrix A, which is negative 4, 4, 3, 3, 3, and 1. I want you to look at the dimensions of these new matrix, of this multiplication. Now the dimensions, now we put them in the form of B times A. Now B has 2 rows and 3 columns. A has 3 rows and 2 columns. So remember that for multiplication to be performed, the middle dimensions, which is the number of columns of the first matrix, must be the same as the number of rows of the second matrix. So those two are the same. And my final matrix is going to be the first and the last, which in this case is going to be a 2 by 2 matrix. That's what my resulting matrix is going to be. So you see that automatically, based on the dimensions, the matrices will not be equal, because this one is only and only going to contain 2 rows, but also 2 columns, like this. That's what this matrix is going to have. 2 rows and 2 columns. Now let's start with the multiplication. In order for me to find the value of the first number, this one is located in the first row, first column. So what you need to do according to the definition is, you need to multiply the first row of your first matrix times the first column of your second matrix. And again, you're going to multiply them in the order in which they appear. The first times the first, which is the 1 times the negative 4, the middle one times the middle one, which is the 2 times the 3, and the third times the third, which is the 5 times the 3, in that specific order. So we're going to do 1 times the negative 4 plus the 2 times the 3, and then plus the 5 times the 3. So it's going to be negative 4 plus 6 plus 15. So negative 4 plus 6 is 2. 2 plus 15 is going to be a 17. So that's my first value. Now, the next one. This one, you see that on the right side, this number, it is situated in the first row, but in the second column. So I need to multiply the first row, which is this same row again, of the first matrix, times the second column of your second matrix. And you multiply them in the order in which they appear. the 1 times the 4, which is the first times the first, the 2 in the middle, 2 times the 3, and the last, which is the 5 and the 1. And then you're going to add those results. So 1 times the 4 plus the 2 times the 3 plus the 5 times the 1. And then you add them. So that's a 4 plus 6 plus 5. That's going to give us a 15. Now, for the next one, this number at the bottom, it is located in the second row, but in the first column. So to find that result, I need to multiply the second row of the first matrix times the first column of the second matrix. Second row times first column, and you multiply them in the order in which they appear. Again, the first ones, the middle ones, and the last ones. Okay, so it's going to be 4 times negative 4 plus 2 times the 3 plus negative 2 times the 3. So that gives me a negative 16 plus 6 and then minus 6. That's going to be a negative 16 as an answer. And at last, we get this value. This one is located in the second row, second column. So what I need to do is multiply the second row of the first matrix times the second column of the second matrix. And you multiply them in the order in which they come, in which they appear. The first times the first, the middle times the middle, and the last times the last. Again. So it will be 4 times the 4 plus the middle one times the middle one, which is the 2 times the 3, plus the last ones, which is the negative 2 times the 1. So that's a 16 plus 6, that's a 22, plus negative 2, that's going to give us a 20. And this gives us matrix B times A, which, like, we can compare A times B, doesn't give us the same thing as B times A. Okay. So these are all the operations that you need to make sure you know from section 9.3. Okay, so that concludes this video.